Hello friends, so let's talk about the variance components in ANOVA with a gauge and a study. So let's go back to PCB Pro, the company that uses a PCBA viewer measurement tool to measure distances between components on circuit boards. In the last section, we used the gauge and R study to look at variation in the measurement system. We saw how variability in the system is split into multiple sources, so known as variance components. So now let's turn our attention to the significance of these components. So which sources of variation significantly contribute to differences in the measurements? Before we answer this question, so let's deepen our understanding of variance components. Remember, variance is the square of the standard deviation. So each branch in the tree corresponds to a component of variation. Notice how each branch builds on the one before to form the total variation. So ideally, the measurement system variation should be very small. We can use this tree to build the equation for total variance. The total variance is the sum of the part-to-part variance and the measurement system variance. And the measurement system variance is the sum of the repeatability and reproducibility variance. And finally, the reproducibility is the sum of operator and operator by part variance. A gauge R study estimates these values for us. So, but where do these estimates come from? The statistical software uses analysis of variance, also known as ANOVA, to estimate these components. So here is the output when we apply ANOVA to the data collected with the PCBA measurement system. The ANOVA mode method is the fourth method the tool uses to estimate the variances. So we can also use the H bar R method. The components of variance are shown here and together add up to the total variance in the system. Notice that each value corresponds to an associated variance in the equation. So what do the numbers tell us about variance in the measurement system? Let's look at the components one at a time to help us better interpret the numerical output. We'll revisit graphs from earlier in this chapter. Here are the box plots of the 12 circuit boards we saw earlier. We can use this graph to better understand both the variance associated with the path and the variance associated with the measurement system. So first, let's consider the path-to-path variance. We can use the same box plots to better understand the second component of variation, the variation caused by the measurement system itself. So each box plot represents a variation in measurement system taken by the different operators for each of the boards. The more variation in the measurements, the more variation in the measurement system. So for the PCBA viewer data, the estimate of the measurement system variation is 0.002558. Both of these variance components add up to the total uh, but add up to the total variation in the measurement system. So based on the numbers alone, a significant amount of the total variation is attributable to the measurement system itself. So as we mentioned earlier, such a measurement system can result in imprecise measurements, which is obviously undesirable. So let's dig deeper into the measurement system variation and try to find the primary source of the error. Recall that the measurement system variance component can be further divided into repeatability and reproducibility variation. So we'll first evaluate the repeatability variation and use the gauge run chart that we saw earlier to help us. A repeatability is the variation observed when the same operator measures the same circuit board multiple times. In the PCBA viewer study, we have 5 operators making these multiple measurements. The gauge run chart is a useful way to see the results of their measurements on each board. For example, here are the 4 measurements made by operator 1 on circuit board 1. Here the 4 measurements by operator 2 on circuit board 1 and so on. You see? So what does this tell us about repeatability? Repeatability is estimated by combining within group variation for all of the 60 combination of operators and paths. For this data, the estimate of repeatability variance is 0.000671. So now let's look at the reproducibility. It can be broken down into variability between operators and variability due to the operator bypass interaction. We'll evaluate uh, reproducibility variation using box plots and an interaction plot graph. Reproducibility is a variation observed when different operators measure the same path with the same device. In the in the PCBA viewer study, we have 5 operators making these multiple measurements. So first, let's do the distance by operator box plots seen in an earlier lesson to better understand the variance among operators. So each box plot corresponds to measurements for each of 5 operators. The differences in these mean measurements are used to estimate the variance component associated with operators. When calculated, the variance is 0.000125. So now let's use the operator bypass interaction graph from a prior lesson to interpret the variance due to the interaction between operators and paths. Notice that the differences among operators are not consistent for all boards. The interaction variance component provides a measure of this discrepancy For this data, this variance is estimated to be 0.000652. The completed equation shows how each component of variation adds up to the total. Generally, it's a good idea to look at the ratio of each component to the total variation to get a relative perspective on its magnitude. So these values are found in the column for percent contribution. Based on the variance components, is the PCBA viewer a precise measurement tool? So this is not a highly precise measurement system. The variation in the measurement system, the total gauge and R accounts for almost uh, uh, almost 53% of the variation in the data. So in a good measurement system, most of the variation should come from part-to-part variation. So based on the gauge and R results, the PCBA viewer is probably not a precise measurement tool, but can we be sure? So does the measurement error have a significant impact on the total variation? In the next lesson, we'll use ANOVA to test the significance of our gauge and R results. Okay, so let's review. A gauge and R study divides the total variability in the data into variance components, and we use the variance components to assess the variation relative to the total variation. Thank you for your listening. In the next lesson, we'll talk about the analysis of variance table.